Right, it seems like we're back online, and I'd like to welcome you to this session on planted pastures and feeding ecology. And we have some really interesting talks lined up. And can I ask the first speaker, Jamie Young, to come up, please? And Jamie is from Barenbrug, and she's going to be talking to us about over-sowing of pastures. Jamie, is Jamie here? Jamie, right. Thank you, and you move with that.
Thank you so much.
Your slides will be there, and the time is there. It's going to count down.
Thanks so much. Morning, everyone. Yeah, I'm Jamie from Barenbrug. So we like to look at ourselves as the pasture passionates. So my presentation is going to be more from an industry focus, more than academic. So yeah, apologies. So the art of pasture in South Africa is really well known. We have some top quality pasture productions from our dairy farmers, thanks to the consultants and the farmers. But just to give it some weight, I thought I'd bring in some statistics. So despite our number of dairy producers declining by 29% from 2019 to 2025, we're now sitting at about 885 farmers. Our milk production has actually gone up by just under a percentage. And to emphasize the efficiency and the extent of the skills in the dairy industry, milk production per producer has actually gone up by 52%. So we know pasture is a key driver in profitability on dairy farms or dairy systems. And that's why we like to consider dairy farms as also grass farmers. So perennial ryegrass is a fundamental component of pasture systems, if not the sole component. And that's because ryegrass has a really great forage quality that closely mimics the requirements of dairy cattle. It's also really high yielding, so 12 to 16 tons of dry matter production per year. And it also has really good regrowth after defoliation or grazing and can recover after grazing. So like we know in life, there's no such thing as a silver bullet. And every now and again, we all need a pick-me-up. For a pasture, that pick-me-up is a stitch. So pasture stitch, also known as an over-sow, is the improvement of a pasture by the introduction of a grass species into the existing sward without disrupting or destroying the initial sward. And we do this to increase and maintain the production of the pasture and also to increase its persistency. So when we speak about pasture persistency, it refers to the decrease in the population of your planted species or the decrease in the expression of a desired trait by your planted species. And research done in New Zealand narrowed this down to 3 factors that cause a decrease in the persistency of a pasture. And that's your interspecific competition. That's either from weeds in your pasture or different species within a multi-species sward. Your sword disturbance at the hands of grazing or cutting or any defoliation that ultimately results in gaps forming in your pasture. And then thirdly is pressure from weeds or invader species. They refer to it as propagule pressure, and a propagule is just a reproductive unit that's capable of producing a new population. So these 3 factors that affect persistency are in themselves also affected by 5 factors. So the first is your species characteristics. So that's the inherent genes of your grass species, your environmental or climatic conditions that your pasture is subjected to, the nutrient availability in the form of either resource, water, or nutrients and minerals, your pests or diseases, which is self-explanatory, and then also your grazing management. So how hard and how low you graze your pasture. So perennial ryegrass, as the name suggests, is a perennial and considered a long-lasting grass. In a New Zealand context, that can be 10 years, but in South African context, that's around 4 years. But with this in mind, there is an inherent drop in production year on year with perennial ryegrass because it's being utilized at such an intense level. So this drop in production, I've illustrated it from Outeniqua's research station that it depicts the drop in production. And this range is anything from 10 to 30% from year 1 to year 2. So obviously it's a very different climate down that side. So we did a similar trial up this side in Underberg, and we saw the same trend with the drop in production. Our values just ranged from 19 to 35% drop in dry matter production. Knowing the value of pasture harvest to profitability of a dairy system, no drop in production, be it 10% or 35%, is really affordable. And this is why we recommend a pasture stitch. It's just to subsidize that natural loss or inevitable loss in pasture production. So once we've decided to stitch, we can look what's in our ryegrass armory. Obviously, there's other things you can include in a stitch, but I'm going to focus it to ryegrass. So your perennial ryegrass is your foundation. It's the longest lasting. And that you can use your perennial ryegrass to stitch into a perennial just to maintain the longevity of it. Then you have the option of a hybrid ryegrass, which is a cross between an annual and a perennial. So it gives you an intermediate growth or lifespan. And then you have your Italian and Westerwolds, which are both considered annual ryegrasses. So your Italian ryegrass has the potential to act as a short-lived annual if it's planted in spring. If it's planted in autumn, it vernalizes, which is extended periods at cooler temperatures that triggers it to go to seed. And in that case, it acts as a shorter annual. And that's why if it's planted in autumn, it vernalizes through winter and then goes to seed the next season. And your Westerwolds is just a winter type ryegrass that only 5-month lifespan and it grows for a shorter period. So when we decide to stitch, it can come down to 2 ways deciding when to stitch what. And the 2 ways is first the easy way, or the second is the right way. So basing it on age is assuming that there's a one-size-fits-all, and we know in nature that's never the case. There's no single recipe that can be applied across the board. So basing it on age, you assume that in your first year, it's really well established. It's almost the perfect pasture. So nothing needs to be done to it. In your second year, you've still got 3 years remaining of that pasture. So you can stitch with the perennial ryegrass just to complement the lifespan of the remaining of the pasture. In your third year, only 2 years left, and that's when a hybrid ryegrass, a 1.5 to 2 year ryegrass could be beneficial. And then your final year, an annual, just to push the production to that last window of re-establishment, although that's sometimes considered condemning your pasture because you're forcing your hand to then re-establish the following year. Okay, so then the right way, and that's using a pasture score. So a pasture score is just requiring a fit in the field. So you're getting to see your pasture firsthand, and it's a score. So it's a ranking from 1 to 5, 5 being a really good pasture, nothing needs to be done to it. A score of 1, condemned, and you want to re-establish it. Anything between those thresholds is a stitch, just to reinforce the felt at different levels. So a score of 2, you want to stitch with a high rate of ryegrass, almost a full sowing rate, and a stitch of 5, just a little something to get it through to the next year, so a lower kilogram per hectare stitch of seed. So why we choose to stitch pastures, it all comes down to money. I think money will speak louder than I can. And to emphasize this, this is research done by the Agriculture and Horticulture Development Board in the United Kingdom. And their initial data tabulated the content of ryegrass in your pasture as a percentage against the income from a product, so be it milk production or meat production, and how that changed as the content of perennial ryegrass declined. So I've just adapted this to South African context in rands, and then with also South African standards. So I've assumed that the energy of ryegrass is about 10.5 megajoules of metabolizable energy per kilogram of dry matter, the milk price of R7.20 per litre, and then I've said that 100% content would be 14 tons of dry matter per hectare, which is achievable. So as you can see, if you've got 95% perennial ryegrass in your pasture, your income from milk production can sit at around 180,000 Rand per hectare. If we drop that by 25% to 75% ryegrass cover in your pasture, that number drops to 134,000 Rand. So that implies every 10% that we drop in perennial ryegrass, you're losing roughly 20,000 Rand of income from milk production. So if we take that back to our pasture score, 70% ryegrass cover would sit probably at about 3 or 3.5 pasture score. So we would say then we want to stitch it at 15 kilograms a hectare to take it back up to the 95% perennial ryegrass content. So then let's see if it warrants a stitch, and let's do the math. So if we can get it from 70% perennial ryegrass to 95% with 15 kilograms of seed, that could potentially give us 46,000 Rand extra income. So the cost to stitch, which includes the seed costs and then any inputs like your labor and diesel, let's say it costs 2,300 Rand per hectare to stitch at 15 kgs. Does it warrant a stitch still? Yes, it definitely does. So if we've got that down pat, we can look at other ways to enhance the seed's survivability or production in a pasture once we've stitched it in. And seed enhancement is the technology of treating seed post harvest, ultimately to improve performance, be it in the form of germination, establishment, vigor, and emergence. And we do this by using a bunch of external ingredients like a liming agent, an adhesive to hold it all together, and then either a biostimulant or a fungicide to achieve this improvement. So the research on coated seed and also on stitching in pastures is very far and few in between. If there's any professors listening to give another study. But the indirect effects of coating seed may have indirect effects on improving seed performance in a pasture stitch. And the two fundamental ingredients in a pasture stitch is your biostimulant and your fungicide. And it isn't either or situation because they're counterproductive, but your biostimulant is there to improve growth of the seed, and your fungicide is an insurance against soil-borne diseases like damping off. So your biostimulant is an ingredient applied to the seed coating, and then it acts within the rhizosphere, so in your root zone under the soil. And in your grasses and your herbs, this biostimulant is in the form of organic carbon chellates that include trace elements to improve performance. And then in your legumes, so your lucernes or your clovers, the seed coating biostimulant is a rhizobium bacteria, which is needed for the nodulation and ultimate nitrogen fixation of your plant. So with the rhizobium coating, it's a nice concept if in spring established pastures, because in spring you might not want to include a broadleaf so that you can spray out for the coming season's weed pressure and then stitch in autumn. So in summary, we know that ryegrass is number one in profitability to pasture systems, and to stitch is the golden thread. And we know that the pasture is going to lose production, and a 10% loss in ryegrass production equates to 20,000 Rand potential loss in income from milk production. But we need to quantify the loss in production year on year so that we know how much to stitch. And the best way to do that is a pasture score, just to make sure we're not under allocating seed requirements and not wastingly over allocating. And then seed coating may be a potential added benefit just to enhance the seed and the conditions it's going to face in that established sort. Thank you.
Thank you very much, Jamie. Now, in this session, we're going to have time at the end for discussion. So if you have questions, please save them, and we'll get the speakers up at the end to answer questions and have a little bit more of an in-depth discussion. But thank you very much, Jamie. That was very enlightening. And our next speaker is Janke van der Colf, and Janke is from a Nikwa Research Station in the Southern Cape, one of the nicer parts of the country. Janke, we look forward to hearing what you have to say.
Hi, everyone. So today I'm going to be talking a little about unraveling the forage quality of pastures under grazing. So just to get started, the data I'm going to be discussing actually forms part of a larger system trial we conducted on Nikwa over 3 years. where we looked at the production potential of 4 pasture systems. So the first was the Kikuyu Ryegrass system, which at that point was kind of like the stalwart. It was the golden child for dairy production from pastures in that region at that point. And then we also started to look at alternatives, like a mixture containing tall fescue, plantain, and red clover. Another one that contained chicory, lucerne, and a ryegrass. And then finally, a monoculture where we grazed tall fescue in the evening and then plantain in the mornings. So if you want to go look at the milk yield and the pasture yield and the pasture composition data, you can follow that QR code and it'll take you to a presentation on that. But let's get back to the forage quality. So when I initially started looking at this data set, I very quickly realized that in a pasture-based dairy system, forage quality and all the other parameters are like puzzle pieces. And what our job is to put them together and then get to a bigger picture so that we can make conclusions and then get to recommendations we can make to farmers on a practical level. So how did I try to achieve that so that I didn't have 600 slides today? I looked at all the forage quality parameters of each system and I then correlated them with the milk yield, and only the ones that were moderately high to highly correlated are then correlated with the different pasture components. So the grass, the forage herb, the legume, and also the weedy components, whether broadleaf or grasses. So I know I'm probably speaking to an audience that exactly understands correlations, but just also to get my mind flowing. So you basically get 2 kinds of correlations in a linear sense. A positive one, which is like a tractor be pulling a trailer. So a positive one, if it goes up, the other parameter also goes up. And when the one parameter goes down, the other parameter goes down. A negative correlation is a bit more like a seesaw. So when one parameter goes up, the other one goes down. Now, obviously, we know that correlations have different strengths, so they can be very weak up to very strong. But for the purposes of this presentation, I'm only going to focus on correlations that were either moderately high or very high. So let's jump into it. So the first correlation set we're going to look at is between milk yield and forage quality of that Kikuyu Ryegrass system, because I feel that lays the foundation for the other mixtures. But we basically found that the forage quality parameters most highly correlated with milk yield were non-fiber carbohydrates, neutral detergent fiber, and dry matter intake. So just to make it clear that that does actually speak to the system, when you plot the milk yield in blue and the NFC content in black over the 3 years, you can clearly see that as the NFC content increases, the milk yielding ability from the pasture increases. Now, the big question is what drives changes in NFC, because we would like to address that somehow. And the biggest contributor that results in fluctuations was the Kikuyu content within the pasture, which was negatively correlated. So basically, if the Kikuyu increases in the pasture, the NFC drops. And conversely, if the ryegrass increases, the NFC goes up. Now, the question is, so what? What can I do about this in my system when I have Kikuyu ryegrass? And the bad news is nothing. This is inherent to the system. You are going to oscillate between Kikuyu dominant in the summer and autumn and ryegrass dominant in the winter. So maybe I can do something about the dry matter intake, right? So just discussing dry matter intake of animals. So the dry matter intake requirements for animals is affected by a whole lot of parameters. Some of them are listed there. And just as many parameters that affect it, there are models and equations to calculate it. But I'm a simple girl who likes things in a simple way. So for today, we're simply going to say that the dry matter intake requirement for a dairy cow is 4% of her body weight. And for our cute jerseys on Otaniqua, that equates to about 18 kilograms of dry matter requirement per day. So that's inherent to the cow. That's a cow characteristic. Then when you look at the pasture characteristic is the potential dry matter intake from the plant. And that's affected by the plant's NDF content primarily, and also a little bit by the cow's weight. And what we need to understand in the system is that when the dry matter intake is higher than what we can get through her body from the pasture, we're going to have to meet that shortfall through concentrates. So that is the highest cost in terms of feed on our farm. It can be up to 70%. So we don't really want to just be pushing concentrates into our animals. So when we plot the potential dry matter intake of the Kikuyu ryegrass over the 3 years, that's the graph you see. But we need to keep in mind that I'm trying to get 18 kilograms of dry matter through my cow in a day. So you can see that line is at all times below that requirement. So it means that the bars then indicate how much more I'm going to have to feed her, probably in form of concentrates. And what's really problematic is that during certain periods, especially during the summer and the autumn, I'm going to have to be feeding half of her diet from concentrates, which can become really expensive. So you kind of say, well, I'll take that punch. I'm going to feed her some concentrates. So our cow's got 4 kilograms of concentrates, and irrespective of that, you can see that the milk yield still dropped dramatically during the summer and autumn. That's in blue when our potential dry matter intake dropped. So again, asking, what can I do about this? And again, the answer is pretty much nothing. It's strongly driven by the Kikuyu content. So once Kikuyu becomes your dominant component, I simply can't get enough food through my animal. So this old adage, oh, but I'm producing like 20 tons of dry matter on my farm from my Kikuyu, it's pumping, it's like a high, I can't get it through my cow, so it's useless. What can I do to overcome this? Well, change the whole system. If we plot the potential dry matter intake of the other system, the tall fescue plantain red clover system, then we see that the intake does actually improve quite dramatically. We're still not at the 18, but at least up until year 2, by the end of it, I am getting more pasture through my animals, so I don't have to feed as many concentrates. So let's talk a little bit about that tall fescue plantain red clover mix. Was dry matter intake the primary driver of milk yield? And interestingly not. The most highly correlated forage quality parameter was metabolizable energy content for this system. So again, just showing you the graph, the blue is the milk yield and the black is the metabolizable energy content, keeping in mind that we want that to be above 10.5 for our hard producing dairy cows. So we see that during year 1 and early in year 2, everything is hunky-dory, we're quite happy, our cows are happy, they're milking. But as we head into the spring and the summer and the autumn of year 2, things kind of like start to fall apart. The ME content drops, our milk yield drops, and then it's all just in shambles by year 3. The ME content has dropped dramatically, and so has our milk yielding potential of the system. So what's the reason behind this? Again, it's changes in sward composition, and the monds that were most highly correlated with ME content was our plantain component, shown in green, and our weedy grass component. So the weedy grasses were things like Kikuyu, Paspalum, Plana, things we didn't really want there. And what was interesting is we found that once our plantain component decreased to below 60% of the sward composition, it resulted in a dramatic decline in ME content, especially during year 3, sorry, which is incorrectly labeled. Then what was also interesting is that once we saw our weedy grasses start to increase slowly above 15% and very, very dramatically in the 3rd year above 50%, the ME content fell apart and so did our milk yielding ability. So the question is, are the forage herbs then always the driver of high milk yield in these systems? And again, the answer is no. So when we tried to look at the correlations for the lucerne, ryegrass, chicory mixture, we couldn't find any real strong correlations. There was like no clear trend. And I thought, well, I'm going to forge ahead and maybe I can at least say the forage herbs still drive the ME content. But again, I almost swore, very poor correlations. So I couldn't really say what was driving milk yield, what was driving quality. Now the big question is, so what? What does this mean for our producers? I'd like to think that the Kikuyu ryegrass at this point is a bit like a child's puzzle. It's extremely simple to understand, it's simple to manage because it is what it is. So what the farmers need to know is that invariably, when the Kikuyu increases seasonally in summer and autumn in your pasture, your NDF is going to go up, your intake is going to be lowered of already low quality pasture, and your milk yield is going to drop. You can't really do anything about that. The fescue plantain red clover mixture is a bit more of a complex puzzle, but if you forge ahead and you manage those complexities, it creates a beautiful picture at the end of it. So here we're going to have to focus on maintaining that plantain component in the pasture. because that's the main driver of forage quality, and that's what supports high milk yield. So we need to keep the plantain in and the weedy grasses out. And then we get to my naughty child, the chicory lucerne ryegrass mixture. When I opened this box thinking I was going to build a puzzle, I was a bit distraught because I opened a box full of random Lego pieces. Then I kind of discovered I was expected to build something, but no one told me what it was or gave me instructions. So from a practical viewpoint, I probably can't make any recommendations to our producers, but from a science viewpoint, it was a valuable lesson. So the first thing is, if there's anyone that wants to help me develop better models and correlations out there, feel free to approach me, because it's probably non-linear and it's probably multifactorial. From a practical viewpoint, this mixture is a bit of a nightmare in terms of changes, in that there was a lot of changes on the components on the spatial and temporal scale. So if you walk into a paddock, you'll find a patch of lucerne, a patch of chicory over there, and then a patch of ryegrass over there. So very difficult to quantify. And temporally, it did this rapid swing about. So it would be ryegrass dominant in the one winter, and then go to chicory in the spring, and then all of a sudden lucerne was there. Then everything would reach an equilibrium, and then the weeds came in, and the lucerne was back. So yeah, very difficult to quantify. So we're going to have to find better ways to do that. And then just lastly, I think because of that, the NIR really struggled to try and quantify the forage quality parameters. So maybe we need to develop better calibration equations for this pasture type, which is unfortunately primarily utilized in the Southern Cape. Thank you.
Thank you, Janke. That was very informative. And I think these first two talks have shown us the degree of complexity that there is in pasture science, pasture management, and trying to get cows to produce milk off pastures. And I always like to see the use of chicory in pastures, because that'll keep it out of coffee, hopefully. And our next speaker is Sigrun Ammann, and she's also from Outeniqua Research Station. And she will be talking to us about biomass production over 3 years of multi-species combinations of 3 functional groups. And again, I think adding to the complexity of the picture that we're seeing in the pastures. Sigrun, over to you.
Good morning, everyone. So Kevin has already alluded to my title. So I'll jump right into it. If I can get this to move. Okay, thank you. So this is primarily about functional mixtures and complementarity in functional mixtures. And so if we talk about functional mixtures, in terms of pastures, we are trying to avoid redundancy, because farmers have to buy that seed. You don't want to add anything that will then just be redundant in the mixture. It also talks to complementarity, because if something is not complementing the mixture, it will also just end up redundant. So the species that complement each other, so that each one can contribute to the biomass. So in terms of the functional mixtures we talk about for dairy pastures, we want a grass, a legume, and a forage herb in the mixture. So the aim is for these functional mixtures to use these rather than monocultures, and this is particularly so in the Southern Cape, where we tend to have drier summers. So it is different to up here where there's summer rainfall. But so we really have to focus on improving resilience in the pastures. We obviously want to improve biomass production, and very importantly, we want to improve forage quality. For this talk, I'll just focus on the biomass production. So this trial ran at Outeniqua. In fact, it's still going at this stage. It's sort of in its final year. So the grass was either tall fescue or cocksfoot, the forage herb plantain or chicory, and the legume red clover or lucerne. And there were various combinations of these three-way mixtures, binary mixtures, and monocultures. Getting into the results, in year one, at the bottom, you can see the different combinations. So in year one, we definitely saw that the three-way mixtures with cocksfoot, plantain, red clover, and tall fescue, plantain, red clover gave the best yields, as did red clover on its own. The mixtures with, yeah, there we go. So the mixtures with chicory as the herb component gave a lower yield. If we then, is this not moving? Okay, so if we look at the composition that was in year one, this is with the cocksfoot, we see that obviously the grass was fairly dominant in the beginning, and then in the summer it moved, the red clover became quite dominant, the plantain remained at around 20%. In the combination with the tall fescue was very dominant in the spring, but it became much less dominant in the summer, and the red clover really was around 50% then in the summer. Oh, oops, sorry, gosh. This is not working well. Okay, in year two, we again had those three-way mixtures with plantain as the herb component as the highest yielding. Also, we had the binary mixture of cocksfoot, plantain, and the monoculture tall fescue as the highest yielding. And then again, the combinations with, this is not really talking to this thing. The combinations with the chicory were lower yielding. So if we look at the composition, again, in year two, the grass was really around just under 30%. In the winter months, the plantain dominated, and in the summer months, the red clover. And it was similar for the tall fescue. So the plantain in the green dominated in winter, and the red clover in the red dominated in the summer. In year three, we see that the three-way mixtures are now falling behind, and it is really the binary mixtures of cocksfoot plantain, tall fescue chicory, and cocksfoot monoculture that dominate the yield. However, the tall fescue chicory treatment actually had no chicory left in it, so it was only tall fescue. And the three-way mixtures now had a broadleaf component of around 10% or below 10%. So the broadleaf component had been lost. So if we look at the composition, we can see that the grasses are starting to dominate, and the broadleaf component is being lost, as you can see over there. The same for where tall fescue was the grass, it started to dominate completely. So what that means is plantain in the three-way mixture is superior to chicory. If we look at biomass production, we find this also just interestingly for the quality as well, which I'm not presenting here in this presentation. And we see also that the three-way mixture is only superior to the binary mixture if the broadleaf component is between 50 and 60%. So the broadleaf component actually is important in driving the biomass production, which seems a bit contrary to what we were believing before, that the grass was driving the biomass production. So we need to develop management strategies to maintain the plantain and red clover components in the pasture over years. We also need to develop management strategies to add that broadleaf component again over time. So how can we under-sow or over-sow, and what are the temporal effects of when we do such actions? So the timing of those events to maximize the establishment of these broadleaf components back into the mixture. And we have to use cultivars with improved persistence because that will obviously help us. Yesterday, I presented the work on the red clover, where we're looking for more persistent types to try and keep that component in the mixture for longer. And we have to do continued evaluation, also of evaluating cultivars actually in a standard mixed sward. So we can't just evaluate cultivars on their own anymore. We need to start evaluating them in a mixed sward. Thank you very much.
Thank you, Sigrun. Again, that adds to the picture that we have of complexity in the pasture systems. And I see a lot of parallels with some of the previous talks that we've had in veld ecology and other areas yesterday, with looking at the role of broadleaf plants or herbs in animal nutrition. Both Cindy and Richard Finn referenced that yesterday in the context of veld. And so there's actually quite a few parallels coming out in terms of the complexity of pasture systems and the complexity of natural veld or grassland systems as well. And that's something hopefully that we can pick up on in the discussion towards the end of the session. But our next speaker is Dr. Neil Miles. And I'd like to call Neil Miles to come up, please. Neil is very familiar with this society. He was a member for a long time. He worked at Sadara in the Soil Science Department, and then later worked for the Sugar Research Institute in Mount Edgecombe, and he's currently his own boss. So Neil, thanks a lot. We look forward to hearing what you have to say for us.
Good morning, everyone. Thanks to the Grassland Society for allowing me to give this talk. And no thanks to Kevin and Rob Walker for twisting my arm to do it. I'm reminded of a saying of Wendell Berry, the American novelist, who said that telling a story is like reaching into a granary full of wheat and drawing out a handful. There's always more to tell than can be told. And when we talk about nitrogen, it's a hang of a complex subject. Teams of scientists have been working on nitrogen throughout the world for crops and pastures. So in this short talk, I'm just going to focus on some highlights. The previous speakers have drawn attention to the type of pastures we're dealing with. So my focus is on temperate pastures like perennial ryegrass with chicory, lucerne included, clovers, of course. And these are expensive pastures to produce. They're irrigated and the seed's expensive. At the other extreme, there's kikuyu, pure swords of kikuyu that are used. This photograph is taken from down in the Southeastern Cape, what they call the Golden Mile along the coast there. And yes, kikuyu really well managed. So kikuyu, not the quality of ryegrass, but if it's managed well, it can be a profitable pasture. So if we look at the nutrients contained in 14 tons of ryegrass, for example, what dominates the picture is potassium and nitrogen. Those nutrients are taken up in huge amounts. They affect palatability of the grass. And I'm not going to be talking about potassium to any extent at all here. It's got complexity of its own. But let's look at nitrogen then. So we know nitrogen is in many respects the accelerator pedal in pasture production. Where soils are deficient in nitrogen, responses to nitrogen are huge and often linear up to very high levels of nitrogen in the grass. So the question we need to deal with is, where does the nitrogen come from for these intensive pasture systems? How much is needed? Where does it come from? And that's what I want to try and unpack very briefly in the next couple of minutes. To look at where the nitrogens come from, we have to look at the nitrogen cycle on a dairy pasture. And what we're dealing with here is the point of work here? No, it doesn't matter. Eyeball. Now it's gone away. What have I done? Okay, next slide. Okay, thanks. Thanks. Which is the laser? This one. Okay, so let's. Now the slides are not moving. Okay. Next. Okay. That's the point. Okay, so if we look at the nitrogen cycle on a dairy farm, the plant takes up available nitrogen in the soil, nitrates and ammonium. Inputs are where the green arrows reflecting inputs. Inputs are fertilizers, returns in the dung and urine, and legume nitrogen, and solely available nitrogen from the organic matter reserves. Each of these are very significant inputs, and let's unpack them a little bit. So looking at, first of all, it returns in plant residues, the dung and urine and legume in. Let's consider legume in. So legumes can contribute significant amounts of nitrogen. Overseas research shows, the New Zealand research shows that typically clovers contribute somewhere between 100 and 350 kilograms of nitrogen per hectare per year. The problem with reliance on legumes is that they tend to be unpredictable in pastures. One year they do well, one year they don't do all that well. And so pasture production is not optimized through the use of legumes. So I'm not going to deal any more with legumes now, but if we look at dung and urine, which is a fascinating aspect, the return of nitrogen through the dung and urine on the pastures. This is complex and a lot of research has been done on this. The excretal patches are of major importance in terms of nitrogen return for pasture growth. A problem is, of course, is that there's uneven nitrogen return on those patches, and they're hotspots for nitrogen loss. Most of the nitrogen in the urine is in the form of urea, and we all know about urea. It's an unstable compound, not the very best fertilizer, but it's the cheapest, and so it's very widely used. So volatilization from urine patches is very high. Leaching losses are very high. 75 to 85% of the nitrogen consumed in the forage is excreted through the dung and urine. 75 to 85%. Typically, New Zealand measurements show that about 100 kilograms of nitrogen deposited in the dung and 350 kilograms of nitrogen total is deposited in the urine. And very interestingly, measurements have been made. The area that the nitrogen received in a urine patch on a per hectare basis, the urine supplies about 1,100 kilograms of nitrogen per hectare in that urine patch, far in excess of plant requirements for short-term growth. So in that urine patch, there's a urine patch growing really well on a nitrogen-deficient pasture, and somewhere between 75 and 1,100 750 and 1,100 kilograms of N per hectare is in that urine patch, mainly in the form of urea. So if any of you have gone into a pasture after the animals have just come out, you've probably smelled the ammonia coming off from those urine patches. A significant amount of loss there. And interestingly, down here in the bottom corner, there's a dung patch with not nearly the amount of growth. So most of the nitrogen in the dung is in the organic form. It's not readily available for the plants to take up. It's got to be broken down and released. Animals coming off the pasture and wandering in roadways, there's significant loss of nitrogen in these animals being off the pasture. Dung and urine deposited in the roadways is lost to the system. So essentially, the system leaks. The pasture system leaks nitrogen through avenues such as this and through this. Now, obviously, some of this nitrogen, they try and return it through slurry and pumping back onto the pastures. But the slurry often tends to be pumped to pastures that are near the dairies, And so the distribution of that nitrogen is not all that effective. A major impact is how much time the animals spend on the pasture in terms of nitrogen cycling. Obviously, the more time they spend on the pasture, the more efficient the nitrogen cycling is. The more time off the pasture, the more nitrogen is lost. And so in this particular example, if they spend 50% of their time on the pasture, a total of about 240 kilograms of N came from the silage concentrates in pasture, going through the animals, through the dung and urine. If they spend 75% of their time, much higher amount of N returned to the pasture. Let's move on then from the excreta, the dung and urine, and let's look at slowly available nitrogen reserves in the organic matter. This is a really complex issue, which many scientists predicting nitrogen release from the organic matter is a particularly taxing thing. And those earlier speakers today and yesterday will have spoken about organic carbon buildup, and I'm going to focus on the nitrogen aspect of that. Now, the slowly available nitrogen reserves in the soil, through microbial action, they're made available for plant uptake in the pasture. And this can be it can be a huge amount of nitrogen made available because organic matter builds up so strongly in pastures. So typically, pasture topsoils contain about 5 to 15 tons per hectare of pure nitrogen. 5 to 15 tons of nitrogen in pasture topsoils. 95% of that nitrogen is bound up in the organic matter. It's not available for plant uptake, but about 2 to 9% is released annually. Those are estimates from overseas research, between 2 and 9%, depending on a number of factors, which I'll touch on shortly. So the crucial question is, let me just go back to that. You can imagine 2 to 9% of 5 to 15 tons of nitrogen is a significant amount of nitrogen. It can vary from about 100 to 500 kilograms of nitrogen being released every year. So it's a huge amount of nitrogen can be released from the organic matter. The crucial question is, when is this nitrogen released? When is it made available for pasture uptake? Well, it's certainly not released like that. There's not a constant release pattern over the year. It doesn't happen like that. We wish it would. And many farmers assume that that's what happens. But that's not what happens. What happens is the process is microbially mediated, obviously. The microbes break down the organic matter and release nitrogen. Very importantly, there's a linear increase in nitrogen mineralization as the temperature increases from 0 to 20 degrees centigrade. And I've modeled that slightly in the next couple of slides. I'll show you, using that relationship, I've modeled nitrogen release in our pastures. It's also dependent on soil moisture status. It's dependent on other factors such as liming, tillage, and the carbon to nitrogen ratio in the organic matter. So the situation becomes pretty complex. Now, if we look only at temperature, that's the pattern that comes out. This is a rough model of nitrogen release over the year, the kilograms of nitrogen per month released over the year. And you can see in midwinter, low temperature, very little nitrogen release. In midsummer, large amounts released. Now, if we look at two different soils with different amounts of organic carbon in them, organic matter. Remember, organic matter is simply organic carbon times 1.72. Obviously, the amount released depends on the buildup of organic matter in the soil. So the higher organic matter, far more nitrogen is released for pasture growth. But the pattern remains the same. That's the pattern of release. So that sort of pattern of release should inform fertilization practices. It should have a bearing on how fertilizer is applied to pastures. And let's have a look at that then. So if we take a typical kikuyu production curve, that's the sort of production curve in the summer rainfall areas of South Africa. Kikuyu growth, I've plotted there against organic matter N release. So what do we find? We find that in August, September, October, the first half of the summer, spring, there's a deficit. There's a huge deficit. Kikuyu is wanting to take off, but the organic matter is not releasing any nitrogen for the pasture to take off. So there's a deficit there. Midsummer, the organic matter is supplying virtually everything the cuckoo needs for growth. Now, you may say this is speculation, but we've applied this sort of model on a number of farms. And it was interesting to me, a farmer who's been applying this for the last about 5 years said to me the other day, he said, just through following this, not applying fertilizer in midsummer on his cuckoo pastures, farmer in the Kapa area, he said to me, I've saved millions and there's been no loss in production. No loss in production, I've saved millions. So just by exploiting the organic matter release of nitrogen there and not applying fertilizer, but concentrating the fertilizer applications in spring and early summer, it improves the efficiency of nitrogen use very, very significantly and can result in significant savings. If we come to ryegrass, I'm not that sure of myself in the ryegrass field, but in terms of this model, farmers have tried it. It seems to be working. But there's the ryegrass sort of growth model. There's Otaniqua people mustn't shoot me down with my model here. But there's organic matter in release. So what have we got? We've got a huge deficit once again in the first half of the summer. And later on, an excess, surplus N. We don't want to be applying more N when the organic matter is releasing a lot of nitrogen, because all we get is high nitrates in the forage, low pasture quality, and reduced intake. So following this sort of taking into account the organic matter N release is very, very important in terms of optimizing animal output, never mind fertilizer. This is a photograph of a pasture taken in midwinter where they weren't applying nitrogen, and that just shows what happens in midwinter. There's no organic matter in release. So in midwinter, that pasture, all that's showing there, the dung and the urine patches, it's very deficient in nitrogen. You would never get that sort of picture in midsummer because organic matter is releasing nitrogen. You wouldn't get that reddish brown color in midsummer. So organic matter is not releasing nitrogen in midwinter. The farmers have to be applying some nitrogen in midwinter, even though the growth is much slower. Okay, this is data from, I just thought I'd show this slide because often overlooked in terms of carbon and organic matter is the role of management and soil texture. These data are taken from thousands of samples in our databases, put them together, and what they're showing, as soil texture, as clay content increases, organic matter levels increase. As when we change from maize, this is tillage, tilled maize, not no-till, as we go from one system to another, there's an increase in organic matter. In our experience, there's nothing that builds organic matter levels like cuckoo. Cuckoo builds organic matter levels fast and to very high levels. So the question we've got to ask, with the expansion of the dairy industry, very often farmers are establishing pastures on previously cropped lands that have been under annual cropping for many years. So what are they doing? They're moving from a low organic matter environment, and they're trying to go, the pastures wanting to move to build organic matter up to high levels. And that costs in terms of nitrogen. Organic matter, to build organic matter, you need nitrogen because the ratio of carbon and nitrogen in the organic matter is somewhere between 10:1 and 18:1. But nitrogen is necessary for the building of organic matter. So in terms of this, there's a requirement for extra nitrogen when we're moving from a pasture to a crop. Now, this is a photograph from the Colf, not far from here. The farmer was establishing, this was taken on midwinter, obviously. This is cuckoo, old cuckoo pasture, very high organic matter levels. This was a previously cropped land. And he's put a pivot in here. And so we were able to say to him, listen, the nitrogen requirements here are very much lower than here because this is in a build-up phase of organic matter. The nitrogen requirements are going to be very high here for some years. Now, we've done some measurements on this. This was some measurements we did on years under cuckoo pasture for a farm at Boston. And look at the carbon, the tons of carbon per hectare. Year 3 under cuckoo, we have roughly 30 tons of carbon. Year 5, we're getting closer to 35. And greater than 10 years, we're close to 55 tons of carbon. Now, I mentioned earlier, to build up carbon, there has to be nitrogen in the system. So what happened to the nitrogen in the system? Well, it just mirrored exactly the carbon. Here's the total nitrogen. We measured total nitrogen. Nitrogen kilograms per hectare has gone from around 2,500 up to close to 5,000 kilograms per hectare as the carbon's built up in that pasture. So during the build-up phase, large amounts of nitrogen are lost through incorporation into the organic matter. So nitrogen lost, as the organic matter builds up, there's a draw on nitrogen. And so what happens, if we look at the typical response in terms of dry matter yield of a pasture to nitrogen, the typical responses are going to look something like this. In year one, we get a very steep response. And the nitrogen requirement in year one may be somewhere, you know, I'm just using this as hypothetical data, but maybe over 300 kilograms per hectare. And that decreases with time. So by year 10, nitrogen requirements are significantly lower. And this is something that's often not taken into account. Farmers say their pasture is performing poorly when meanwhile it's been established on an old cropland. It takes years to come to equilibrium. I'm ending now. What I also wanted to say is, I'm making a point here. There's a gap in the leveling off of the yields. By year 10, the yields pasture is producing much higher than it is in year 2 or 1. Simply because as organic matter builds up in the soil, so soil properties improve. And the potential production improves very significantly. So we know all the benefits of organic matter to improve soil health and soil properties. So that gap is very important there. So what I've tried to cover in the last few minutes is nitrogen is necessary for pasture production, for optimum pasture production. The system leaks. It leaks through excreta. It leaks through immobilization of nitrogen into the organic matter. The system leaks nitrogen. And if one goes onto a pasture system with zero nitrogen, production inevitably is going to decrease with time. A farmer can get away with it for a couple of years if organic matter levels are very high, but production is going to decrease. So losses of volatilization from the excreta, excreta in roadways and holding yards, leaching of nitrates in soils, buildup of organic matter, runoff losses. Kevin asked me to focus on some research needs, and really there are massive research needs in this sort of work. Very little's been done in South Africa. The impact of soil texture on soil organic matter buildup is a fascinating subject that there could be a really interesting research program. Timing of nitrogen release, those models I've shown there are very crude, and the timing of nitrogen release from the organic matter on these intensive pastures could be a very exciting field of research with plenty of opportunities. And then ryegrass, different pasture systems with nitrogen requirements. Janke was talking about stitching in, and previous speakers were talking about stitching in. Nitrogen requirements in those complex systems certainly requires research. Thanks, Kevin.
Thank you very much, Neil, and we'll take questions at the end. But again, I'm seeing quite a few parallels with previous sessions that we've had yesterday. And for Heidi and other people working on soil carbon, you've got the answer. Just plow out everything and plant kikuyu, and you'll build up your soil carbon quite quickly. I'm sure that's not the answer, but I'm sure Heidi and others will have questions for Neil about the soil carbon dynamics. We're moving on to the last speaker for the session, and this is Jane Holliday. And Jane has worked in the dairy industry for a long time and the beef industry, and she's quite a high flyer with intellect and got a lot of experience. Jane, we look forward to hearing what you have to say. Okay, that's the pointer. Next slide, back. Don't worry about the timer down there. You've got as much time as possible.
Thank you. Good morning, everybody. Thanks for having me. I usually speak to farmers, so this is a little bit different for me. The topic today is effects of leaf stage and residual height on ryegrass productivity and persistence in dairy systems. So Intellect is a consulting company. We have a division in New Zealand, Australia, and in South Africa. And a lot of our work is around benchmarking. And we use our benchmarks to provide advice to farmers across various aspects of their dairy systems. So I'm going to chat to you a bit about the benchmarks in relation to pastures, briefly about irrigation management, not my forte, the rising costs of ryegrass, which is a concern, grazing management in terms of persistence, ryegrass types, and ryegrass quality. So why is pasture management important for dairy farming? The previous speakers have alluded to the answer. It's about money. This is how we make money for dairy farmers, by growing good quality and a lot of pasture. So every year, with the kind help of Craig Morris, I bother him after we do our benchmarking, just to make sure that what we're seeing in the data is relevant to South Africa. My New Zealand and Australian colleagues love to tell me exactly what's driving profitability, but we just like to keep an eye on them and make sure that those things are in fact relevant to our system in South Africa. So this is a list of some of the variables and how they are correlated to return on capital, which is our measure of profitability. So in this type of data, I'm told by the clever people, if you have a relationship of over 0.3, is reasonably strong correlation, not like Janke's scientific trials, for survey data, which is pretty much what this is. So if I have a look here at pasture tons grown per cow over the years 2018, 19, then we had COVID, 21, 22, 23, and 24, most years it's around about or just over 0.3. And if we look at pasture harvest, tons dry matter per hectare, we can see in every single one of those years, it's well over 0.3, and in fact, most years over 0.5. We obviously don't want to compromise our milk production, so we use milk solids as a percentage of live weight to compensate for brown cows and black cows and big cows and small cows and all sorts of different shaped cows that farmers get very emotional about. So we don't talk about litres per cow, we talk about milk solids as a percentage of live weight. And obviously that needs to also be pretty good in order to make some money. After all, we are selling milk. And then we look at grazed feed per usable hectare as well, to just make sure that we're managing. What we're starting to see, this is a newer thing we've been looking at since 2021, is actually what is the link of all grazed food across all classes of animals on the farm, the link to profitability, not just your lactating cows. And this is also turning out to be quite a strong correlation to profitability. So grass all the way. This is some data we've collected over the years, looking at actually what's happened on farms. So the last year was 74 farms that we benchmarked. We're about to do it again, coming up next month. But from 2011, 2012, up to 2023, 24, these are sort of the pasture, what we're managing to get down the cow's throat. So this isn't grown. This is what's been harvested by the cows, which we work using a back calculation from litres produced, minus the silage, minus the concentrates fed. We get an estimate of what the pasture's eaten. So you can see there's possibly a minor increase, maybe going from sort of 11.25 tons to closer to 11.5 tons. Not much improvement in our pasture harvest per hectare. So this is where our clever people are going to have to help us out here. Obviously, we've got weather events that are bothering us. Drought, fertilizer prices, I think, were the main reason for the dip there. Then we've got grazed feed per cow. Also, we managed to lift that a bit. Our farmers are doing a better job of actually getting grass into the cows. Lifted marginally from about 2.4 tons, close to 2.5 on average. But there are some guys doing a really, really good job, and girls in the study group. Our top guys got just under 20 tons of grass harvested per hectare. And cows, some of them are managing to get at least 3.5 tons of grass into their cows, although the average was 2.5. This is the slide that's a bit of a worry for me. Obviously, grass is still your super cheap food. This is direct costs. I'm not taking the capital value of the land and whatever into this. But if we look at what's happened to the price of grass since 2021, it's scary. And you know what the reason for that is? Eskom. It's still cheap, But yeah, it's more than doubled in value over that short space of time. So getting on to irrigation in Eskom, Neil Miles has just told us how we have to look after the soils in terms of fertilizer, but if we're not getting the water onto the grass, well, we're fighting a losing battle. This is a paper done by Richard Rawnsley, and it shows the impact of irrigation startup delay on your pasture harvest. So you might be getting a whole lot of things right in terms of grazing management and fertilizer, but if you're not starting your pivots when you're supposed to be, you're going to be losing a lot of dry matter. And in this case, you can see here, probably about 700 tons dry matter for a week delay. If you're still asleep 2 weeks in, you're probably losing about 1.5 tons. Now remember, on my previous slide, the farmers were harvesting about 11 to 12 tons dry matter a hectare. So just because you fell asleep for 2 weeks, now you've lost 1.5 tons of that. So as I said, yeah, your pasture harvest could drop potentially from 12 tons to 11.3 for the year because you delayed irrigation startup on that one grazing round. Fortunately, there's some really good tech out there. Certainly looking at international data, I think our South African people are pretty clever. A lot of the farmers use EriCheck Pulse scheduling software. So that'll tell them nicely what's happening in the soil with the moisture, but it does need to get calibrated often, and often people don't calibrate it often enough to see the results. And then it doesn't work so well, it can work against you. But it'll give you an idea of what moisture is happening in the topsoil and the bottom soil. In winter, it really helps a lot with over-irrigating. And it also has temperature and the different soil depths, so we can also get a good prediction on what's happening with growth and where that growth and where we're heading, like a week or two's time, with our irrigation requirements and possible pasture growth rates. So why is grazing management and persistence important? We've heard about that, but the one thing that worries me about it is this huge loss of potential in autumn. We still got reasonable temperatures then, we got reasonable growth rates in our pasture, and we force a deficit on our cows because we take out pasture, we're re-establishing that 25% that scored at 1 there on the previous presentation. So we're still able to probably get about 8 or 9 kgs of grass in, but no, now we've got to take that grass out because we've got too many weeds in it, hasn't persisted, it's no good. So our cows now go down to about 4 kgs of grass almost overnight. And then obviously as we warm up through spring, the pasture comes back. So that the cost of that, let alone the seed, the downtime, you've got to feed concentrates and silage there, which you've seen on my previous slide, how expensive they are. So there's a big cost to that. So to get onto pasture persistence, which was the title of my presentation, if we look at this from the NZ Dairy website, this is our leaf stage and grazing management. You can see from 0 to 1 leaves, we grow about 15 to 25% of our grass. From 1 to 2 leaves is 35 to 40%. And from 2 to 3 leaves, you double your pasture dry matter. It grows 45 to 50% of the dry matter is grown at the 3-leaf stage. Obviously, if you graze the grass too soon, here you're sitting with high protein and low fiber, which might not be too good for your cows. That's when it's like water coming out in the dung. And obviously, if you're going to wait beyond 3 leaves, your first leaf is going to die because a ryegrass plant will only grow 3 leaves at one time. So you've wasted a whole lot of money growing something that you never bother to eat. So it's very important to time that correctly. Similarly, if the grazing rotation is too quick, you're going to kill your grass because if you're grazing at 1 leaf, there's not enough energy to produce a new leaf. So you're diminishing the strength of your root system. If you graze between 1 and 2 leaves, probably a bit of photosynthesis happening from the first leaf that grew, but it's better to graze between 2 and 3 leaves because then your plant is strong enough to handle the grazing events. So I looked at a trial done by Richard Rawnsley et al., which was done in 2014, which was quite nice because like the work that's done in Outeniqua is looking at not just one season, it was looking at work done over 2 years. And it's quantifying the interactions between grazing interval, grazing intensity, and nitrogen on the yield and growth rates of dry land and irrigated perennial ryegrass. So this work was done in Tassie, so it's a bit different to here. But they looked at dry land versus irrigated pasture. It's obviously different because it's winter rainfall, not summer like KZN. They compared residual cutting heights of 30 millimeters, 55 millimeters, and 80 millimeters. And you'll see from the New Zealand work, for those of you familiar with grazing management, they recommend almost like a golf ball. You graze your grass right down because it's a waste of money not to have a really good residual. But this turns out in this trial that it might have some impact on the persistency. And then they also looked at grazing at 1, 2, or 3 leaves. There's also a nitrogen aspect to this, but I left it out because I figured Neil would have covered all that. So what we saw is that leaf stage and grazing management and the right leaf stage to graze is very much dependent on moisture. So if you have a very well irrigated perennial ryegrass pasture, you can graze your grass. This is the irrigated grass. Whether you graze it or 2 or 3 leaves, it's not really significantly different in terms of your accumulated dry matter yield over that time. So if you think about it, I know I just said in the previous slide, you gain 50% of your dry matter grazing at 3 leaves as opposed to 2, but you're probably going to fit a couple more grazing events into this time frame if you're grazing it closer to 2. However, if you are water is your problem, you haven't got Eskom or you live in a dry part of the world, you better be grazing at 3 leaves because there's a massive difference there between 2 and 3 leaves. So leaf stage advice to farmers on grazing management is very much dependent on irrigation. So if I did a thing here, Jamie, you'll be impressed with my little pictures. I did, if we graze at 2 and 3 leaves compared to 1 leaf, resulted in 41% and 31% higher tiller densities compared to grazing at 1 leaf after 18 months. So then I looked at it in terms of buying seed. If I was going to go full rate on my 100 hectares of farm, and I was going to go 25 kgs a hectare because all my scores are 1, I'd need 100 bags of seed. It's quite expensive. If I graze at 2 leaves, I'll only need 60 bags of seed. And if I graze at 3 leaves, well, it's much the same, but maybe a little bit more, it's 68. In terms of residual, what was interesting for me is grazing continuously flat and trying to get as much out of each grazing round as possible actually wasn't very good for persistency. So once again, we had a 31% and a 47% reduction in tiller densities at grazing at the higher residual compared to the 30 millimeters. So once again, using my bag analogy, if we consistently graze the grass right down because our cows were starving, we'd probably have to redo the whole platform in autumn. If we decided to graze to 5 centimeters, which when I was at school seemed to be the desired residual, we'd probably need 69 bags of seed. But actually, if we leave a little bit more behind, it does better for persistency when we get back to autumn, which was quite interesting and quite different to what the New Zealand work says. So you might ask, why do we possibly have poorer persistency grazing at 3 leaves compared to 2? It's because at certain times of the year, when you've got lots of nitrogen coming from the soil and top dressing, and you've got lots of moisture, and under ideal conditions, you will end up with canopy closure at 3 leaves, and it will be better in that instance to graze at 2. And what canopy closure is the failure of light to get to the base. We'll end up with aerial tillering here. So if you think about the ryegrass plant, that's supposed to form a new tiller, but now it's up in the air. It's never going to make soil contact. When the parent plant dies off, you're going to end up with gaps in your pastures for all those weeds and undesirable plants to come in. So Jamie, would probably be better to talk about diploid and tetraploid ryegrass. And there's been a lot of chat this morning about mixed species. I tend to find tetraploid ryegrass doesn't seem to work too well on my farms. I find that although it is higher in energy and there's more milk from the cows because it is a better quality grass, it doesn't persist. And we end up having to take out more grass in autumn. It's because it tastes better. It makes sense the cows would eat it and they'd probably hammer those residuals a bit harder down to the 3 centimeters. And also doesn't like wet conditions and we're a summer rainfall area. So we see a lot of pugging. And I mean, they always say you should take the cows off the pastures when it's raining, but a lot of people don't have that luxury on their farms. So I generally find the diploid is more robust, has a denser sward, tolerates wet conditions, and is more persistent. So we have less downtime in autumn. So make the right grazing decisions. When there's not enough moisture, you must graze at the 3 leaves. That's very important. When there is enough moisture, not much difference between the two, but you need to avoid canopy closure, and an extensive root system is needed under drought stress conditions. This is one of my last slides. It's just an interesting slide on whether the new varieties of ryegrass have better quality, and this is taken from the Meadow Laboratory, which is NRR, so I don't want to speak to its calibration accuracy or whatever, but over time, I think there must have been an event here where they recalibrated it, but if you look at it even over that space of time, which is 2019 to 20, I can't really see behind me, but I think 2022 it was, you'll see that the orange is the fat content of the grass, which would be driving energy. And there has been a little bit of a lift, but not much, but there has been quite a significant, I think, decrease, it looks like in the trend, it's not scientific this, in the NDF or the fiber. So it looks like the quality of our ryegrass has improved with the clever breeding from the clever people. So our ryegrass NDF from this data ranged from 28% in August to 55% in March. So in summary, grass is essential for profitable dairy farming. Persistency is vital in saving money on seed and reducing autumn downtime. Pasture quantity and quality are essential. Leaf stage and residual management are key. Correct irrigation, scheduling, and fertilizer applications are vital to benefit from good pasture management. Thank you.
Thank you very much, Jane. That was extremely informative, and I'm quite sure we're going to get quite a few questions on that. We're running ahead of time, I think, for the first time in the Congress. So we have got quite a bit of time for questions, and I would like to ask the speakers, please, to come up and stand in front, and then we'll take questions from the audience. So if I can have someone with a roving mic, please, and then we can start taking questions. Just looking back at Jane's talk now and looking particularly at the pasture management, grazing at different leaf stages, etc., it made me think of Richard Finn's talk on yesterday, about stages of grazing, looking at managing felt for quality, and I'm sure there's some parallels there as well. Not sure if Richard's here, but hopefully he'll get to ask a question as well. I see everyone standing really far away there, but yes, can we start taking questions, please, from the floor? Yes, in front here. Do we have the roving mic? It's coming.
Thank you, Chair. I wanted to ask, the lady was talking about the dairy milk cows. Yes. What breed did you use for your research, or it was just generic?
Can you hear me? Okay, yeah, it wasn't my study. It was more of a literature review. So from the New Zealand data, it's normally Holsteins, so the black and whites. Yeah.
Thank you. Next.
Thank you. I think this question goes to Janke, if I'm calling it correct. If I get it correct in one of your slides, when you're talking about NFC, particularly in Kikuyu, it's negatively correlate with the production milk yield. If I get it correct, I'm just a bit curious, what could be the possibility? Because I would think it would have provided more energy, which is required for production in terms of energy in relation to fiber.
Yeah, the positive correlation was NFC was positively correlated with milk. So when the NFC went up, the milk went up. But the NFC content was negatively correlated with the Kikuyu content. So Kikuyu would drop our NFC and then drop our milk. Does that make sense? Yeah.
Thanks. And we have a question there. Urs?
There we go. It's good to see you, Neil.
Good to see you, Urs.
My question was, in your nitrogen dynamics model, there was no arrow between inorganic nitrogen application and microbial action, particularly nitrogen fixing microbes. My understanding is that nitrogen application over long periods of time can actually depress those populations of nitrogen fixing bacteria, which has a negative feedback on the system of conversion of organic matter into plant available nitrogen.
Yeah, no, Urs, you're quite right. I just didn't go into that sort of detail. I didn't put that into the flow chart. But I mean, there is a nitrogen fixation into the organic matter, immobilization, if you want to call it that. There are a lot of complex effects. There's also the impact of inorganic nitrogen on clover performance, on the rhizobial fixation of nitrogen, and what you're talking about now. So yeah, I just didn't go into that detail.
So, sorry, I don't want to take over, but somewhat related to that, you pointed out that in fields that have previously been cropped, the application of nitrogen at the beginning is really important. But what about the application of organic matter to try and minimize that nitrogen requirement when you're converting a field from cropping to pasture?
Yeah, you're right. But the problem is with the addition of organic matter, farmers are limited in what's available. It's huge amounts of organic matter to build organic matter levels. Generally, it's not available. Farmers can try some cover crops, but the amount of nitrogen, the amount of organic matter buildup on conversion of an annually tilled cropland to pasture is huge, and so it's a matter of time for that organic matter to build up, and of course associated with that is the nitrogen immobilization of nitrogen in that organic matter.
Thanks, Urs. Are you happy with that, Urs? Okay, Wayne.
Thanks everyone for great presentations. My question is to Neil. Neil, to what extent do you consider soil compaction and the effects on the nitrogen dynamics? Is it a consideration or concern?
Yeah, soil compaction it's part of the whole soil health conundrum, and obviously it affects plant performance and organic matter accumulation. And compaction under intensively grazed pastures can be very significant. Can be particularly shallow depth because of hoof action. So that's just an aspect requiring research. We haven't done work on that. We've identified compaction, but the implications in terms of nitrogen dynamics we haven't got to.
Thank you. Next question. Thank you.
Thanks. Thank you for that, for those nice presentations, and they're quite clear. My question is on the mixtures, or the forage mixtures, where the presenter presented about the mixture between the ryegrass and the kikuyu. What were the ratios between the ryegrass and the kikuyu? My question is informed by the different growth forms between the kikuyu and the ryegrass, because kikuyu tends to outcompete some of the grasses because of the different growth form. Did you measure or did you add equal amounts of the kikuyu and the ryegrass, or
are you done? Sorry, I can't even see where you are. There you are. Okay, so I didn't run through the changes in pasture composition separately for the kikuyu ryegrass. That is in that other presentation. But you'll continuously have this oscillation between when we over-sow in the autumn, it'll be ryegrass dominant up until about November, and then we'll start to see a gradual decline, and then it'll become kikuyu dominant in the summer. So that just organically happens in the system. And then in the autumn, we'll go back and we'll stitch in the ryegrass again. So, and I don't have the values because it's over 3 years, but it will be kikuyu dominant, so more than 50% in the summer and the autumn, and then it'll be ryegrass dominant more than 50% in the winter, if I have to kind of rough it. Does that answer your question? I can show you the data after the presentation that's a bit more detailed. But yeah, the kikuyu does inherently outcompete the ryegrass, because the ryegrass in our area in the Southern Cape actually doesn't compete very well. The temperatures are too high. Sigrun knows better in the night, and the moisture stress, it just goes out by itself.
Thanks, Janke. Next question there.
Yes, my question is to Sigrun about the biomass production presentation that she alluded on. Yes, I just wanted to ask, as much as your presentation focused on the improvement of biomass production of these functional mixtures, is there any literature, or does your study go beyond and look at the influence that the functional mixtures have on milk production?
On milk production?
Milk production, yes.
Okay, the milk production was measured in Janke's systems trials. So you should probably answer that one.
Okay, so yeah, how we function our research is Sigrun really does the foundational work, and then I take it over and I take it to grazing trials. So we did evaluate the milk production. It was still early days, so we kind of selected the mixture we thought would be most functional, which was that tall fescue red clover plantain mixture. And then later we included the chicory, lucerne, ryegrass. And what we found was that the forage herb-based mixtures definitely outcompeted the kikuyu ryegrass in terms of milk yield, particularly during summer and autumn, during year 1 and year 2, when composition was still good of the pasture. I hope that answers the question.
Thank you. Got a question there from Darren, and then here in the front. Sorry, there and then the front.
Thanks, Kevin. Jane, I'm asking you this question because Siggy and Janke are in the naughty corner there with you. That jump in unsaturated fats from the NRS at meadow feeds, it seems to have become a thing, but not just from meadow feeds. Can you comment on whether that jump is NRS and they're going to the same calibration, or where this is coming from?
Did ask around whether there was a specific change in varieties that were being sold in South Africa at that time, and I couldn't really find anything. I mean, 150's been around for years and years and years, and I think Barenbroek hadn't brought anything in over that time, so I think it was probably a calibration thing. But high fats and grass are a problem for us. We have massive butterfat suppression in our cows from now on until the fiber levels pick up, which I didn't see as much of that like 10 years ago. Got a plant fescue, apparently.
Thank you.
Neil, I've got a question for you. You mentioned that we need to be putting nitrogen down in spring and summer. Is there any merit in putting nitrogen down while that kikuyu is dormant in cold areas, and when should we start applying?
No, it's not going to make any difference to production if you put it down while it's dormant. You just got to hope that it doesn't get lost. So I know some farmers fertilize quite heavily in autumn because they say they don't want to miss the spring. It's coming away in spring. But yeah, I would rather just go into late August or September with my first dressing of nitrogen, because there's always the danger of some loss during the winter if we have winter rain. So, and there's no point in putting it down in midwinter. Yeah, kikuyu's not going to, below 10 degrees, nighttime temperatures of 10 degrees, kikuyu's just not performing.
Thank you.
Thanks. And in the front here.
Yes, my question is also addressed to Neil. Wondering if the high concentration in nitrogen level in your models could be attributed to maybe non-precision application of fertilizers. Do you know if the farmers maybe practice precision agriculture? I know it's mainly adopted in the crop industry, where they spot which spots within the farm they have to apply these fertilizers. Thank you.
So is the question, is it due to the application of fertilizers, the high nitrogen? Well, you can use precision fertilizing. It would rather be, the problem with precision use, with precision, are you talking about a GPS-based precision agriculture like they use for phosphorus, potassium, and other nutrients? The problem, there's not a reliable soil test for nitrogen. That's your first problem. Okay. So using those models is probably the temperature model that I put up there. Temperature organic matter release is probably the way to go. But if your question is about precision, using precision applications for nitrogen, it's very tricky.
No, I'm asking if the farmers practice those precision application, or do they just,
No, No,
when
that-
it's time to apply the fertilizer, they apply across the whole field, or they spot specific patches within the farm which maybe need a fertilizer application?
No, they apply the same rates across the whole farm generally.
Okay, noted.
Yeah.
Thank
Thank you. And we've got 3 questions at the back. I think Wayne is next, and then 2 people behind him.
Thank you. My question is for Jamie. Jamie, with regards to your stitching recommendations, do you consider intra and interspecies competition when you make the recommendation? And to what extent does it affect the germination of that seed stitched in?
Thank you, Prof. So the rate is pretty much just based on the cover. I mean, Jane will know better than me, but also the success of a stitch isn't as good as it should be. I don't have data to back that up, but we say roughly 30% effective. And a lot of people contest that because it's a higher expense if you know you're only going to get 30%. But if your drop in production is only 30%, you just need to subsidize that. So you don't necessarily need a 60% take. And naturally the germination, it's because of that. It's not as great because you don't get that seed to soil contact and the conditions within that sword. That competition does outcompete the seedling. And that's why it's quite nice to consider the hybrid ryegrasses or your annuals, because they tend to be quicker out of the block. So once you've grazed it, that's when you do your stitch and your top dress. And then it just gives a fighting chance because they're quicker out the blocks. They can compete with that sword.
Thanks, Wayne. You happy? And then next question. Where's the next question? There. Okay.
Hello, my question is to Sigrun. When you looked at the biomass production of the multi-species, I want to ask did you rather check also if how the biomass production was affected in seasonal changes, considering that some species are winter dormant and some are winter active, or you only looked at when they were active at the end of the year or during the summer season only?
Okay, we actually did composition at every harvest. So we have lots of data of how the composition changes and how each component contributes. But I only presented it here now on a seasonal sort of, just a snapshot of some of the season. So we have lots of data at every harvest. So whatever the rotation was, like 30 or 35 days, we also determine composition. So you can see how the different components contribute more or less as the seasons change.
Thank you. I think there's another question at the back, Debbie, probably from online.
So this is an online question from Martin Tinnefeld. It's actually a comment, and the first one is directed to Jamie. He says, your iron content in the soil post initial seeding is pushing up your lignin content, i.e. soil maturation post disturbance for planting or fertilization. Factors such as soil compaction and microbacterial maturation within a rotation management system impacts on the release in iron of the soil, impacting on the water quality, which is available for plant uptake, increasing flashing or reduction and loss of iron by resting with lignin-rich vegetation, absorbing the iron or draining it through percolation, which is likely redundant as pastures are usually on low permeability soil, clay content. Also, you don't want to saturate the soil. The conclusion is manage your soil iron. And then just another comment to Janke, your soil iron is also going to be affecting your leaf size and palatability. Any feedback on that comment?
No, thanks. I think that was a fairly comprehensive comment. and yes, and I think that if the person online is welcome to contact the speakers directly via email, and we can make email addresses available to carry on that discussion, please. Further question, there was a question in front. There's a question in front over here. First, the mic is there, and then we'll come to the front. Thank you. Please carry on.
Good morning, colleagues. My name is Patrick Ragau. My question will be directed to Jane. Your study talks about the effect of leaf stages and residue heights on ryegrass production and persistence in dairy system. And on your discussion, on your presentation, you were talking about the recommendation of grazing ryegrass at 2-leaf stage. And maybe I didn't get it, but where I'm seated, isn't it genetical behavior of ryegrass to lose their leaves, like after the fourth leaf, the first one dies. So the recommendation of grazing at 3-leaf stage is based on its call it genes genetically. So is it the issue of nutritional value or the issue of a genetical trait for ryegrass to be grazed at 2-leaf stage?
So it's best for quality and quantity purposes to graze it between 2 and 3 leaves. If you're targeting 3 leaves, you run the risk of maybe going a bit over, and then you'll start to get dead material and a buildup of fiber, which won't be good for the cows. But if you target between 2 and 3 leaves, you should avoid the loss in quality and the loss in quantity through decay. Does that answer your question?
Thank you. Where are we with the microphones? Question in front here. Thank you.
Thanks so much, Neil. I was just wondering whether, what you looked at in terms of the seasonality of when it's best to apply fertilizer. Have you looked at perhaps doing a nutrient balance at farm gate to see what percentage then would be excess nitrogen? Because I think that coupled to your findings, I think that would be so convincing to farmers in terms of how much loss, and could be quantified in terms of rands and cents loss by just applying it, and then it's going to be lost out the system, but also such an environmental gain, because you could see, okay, all that excess is likely to be going somewhere, and from a water quality perspective, that's probably going to end up in a river. So I just wondered if you thought of doing a nutrient balance along with that to sort of add to the motivation.
Yeah, that's just so interesting, the point you raise. And we haven't done any work on that. We've looked at New Zealand work and UK work where they've looked at those sort of balances, but our systems obviously are different. I think that's just another aspect that's a real research need. And there's probably a surplus of nitrogen in midsummer months where a lot of farmers just continue to apply nitrogen, fertilizer nitrogen through the summer, not taking into account that sort of model that I was putting up there. So the amount excreted is huge in the midsummer months, January, February, March. And at the farm gate, as you're saying, there could be the environmental implications of that, the inefficiencies that it introduces can be very significant. And that to me is just another very exciting avenue that could be researched. Yeah.
Thank you. And we have a question from Justin.
Thanks very much. So this is directed to Jane, but also to others, if they could comment. And that is that farmers face, as you've demonstrated, unexpected price hikes and things. So you gave the example of the cost of producing pastures, but I suppose other things like fertilizers and diesel and all sorts of other things could increase. So which factors are likely to increase in price in the future, do you think? And in the South African context, what should farmers do in order to be able to try to absorb these price increases without going under?
So what I'm seeing on my farms, well, Eskom's going to be a problem. I don't know what the ceiling is on that. It's going up and up and up. And we're looking at technology to try and use power more efficiently, pumps and just losses, trying to reduce them maybe consolidate transformers, all that type of thing, just to try and get on top of that bill. So that's the one thing. But what I've noticed is it's a bit like the work in Oats and Eco is done on one land with the mixed pastures. What I found, because of our summer rainfall, there's actually quite a place for kikuyu. We've kind of gone off it. But now I've noticed in some of our really high-performing Holstein herds, we can put certain cows on kikuyu for certain times and not lose milk. Sort of maybe younger cows, later lactation cows, 12 hours a day, graze your dryland kikuyu, and then graze a portion of the diet to be the expensive ryegrass, trying to get on top of the total feed costs in the system. So we're looking at drylands. I've got other guys that have planted fescue dryland successfully. Same again. That's what we're doing at the moment. There are some farmers that have gone off grid, but we're sort of looking at 20 to 30 million rand investment for that. So not everyone can do that.
Thanks, Justin.
I don't know if Neil's got a comment about fertilizer prices going forward in the war.
I think Jane's hit the nail on the head. The thing is Eskom that's really put a lot of farmers in a corner over the last year or two. Fertilizer prices are always up and down.
Maybe I can just add, so our approach in the Southern Cape is to try and really focus on deeper rooted species for the pastures so that the pressure on irrigation is reduced. We already are in an environment where summer can be dry and irrigation can be limited. So we feel that at least for our region, some of that pressure of Eskom can be reduced by changing to deeper rooted species. So you can use more of the soil volume to extract water and thereby reduce your irrigation inputs.
Thank you. We have a question, and Ntuthuka has a question at the front. Have you got a question at the back first? And then if you can come to Ntuthuka, please.
Oh, Sevi.
Thanks, Ntuthuka.
Thank you, Kevin. Mine goes to Jane. Jane, just before you finish talking, you compared tetraploid with diploid, and you said one of the two did not work for your farmers. I was curious about the conditions under which each one of them would be suitable, just for my information, maybe also information of others who might benefit from it.
Maybe I should ask these people here to answer your question. They probably know more about the actual differences beyond what I said. It's just my observation. It's struggles in the high rainfall areas with the pugging. Maybe you can comment on Eastern Cape because the Western Cape.
So yes, there is a problem, I think, with the pugging, with the tetraploids being softer, but you do have, and also the grazing height. So, you do have the issue of, you do have want to use tetraploids because of the better quality. So the way we approach it in the Southern Cape, we actually plant mixtures of diploids and tetraploids to try and sort of mitigate that effect. If we do have just pure ryegrass pasture, we would actually plant a mixture of those types.
Thank you. You happy, Ntuthuka? Thank you. And I think that brings us to the end of the questions and to the end of a very interesting session and a very interesting discussion session. So can we have a round of applause for the speakers, please?